Today's lesson is about climate change and glacial fragility. We have already looked at how glaciers shape landscapes, how people use glaciated areas, and the conflicts that can happen in these environments. Today we are going to look at what happens when these environments begin to change rapidly. Glaciers may seem huge, powerful, and permanent, but they are actually very sensitive to changes in temperature and snowfall. That is why they are often described as fragile environments. By the end of today's lesson, you should understand how human-caused climate change is affecting glaciers, why melting glaciers matter globally, and how fragile glacial environments can be managed. Let's look at our learning objectives. By the end of the lesson, you should be able to explain the link between anthropogenic climate change and glacial retreat. You should also be able to evaluate the impact of melting ice on global sea levels and fragile ecosystems. We will analyze a real case study, the Mer de Glace in the French Alps. Finally, we will review some management strategies used to protect glacial environments and think about whether they are effective. The key skill today is not just describing what is happening. It is explaining why it is happening, and then evaluating how serious the consequences are. Before we go further, we need to make sure we understand some key vocabulary. The first word is retreat. In geography, when we say a glacier is retreating, we do not mean the whole glacier is sliding backwards. A glacier may still be moving downhill, but if it is melting faster than it is gaining new ice, the end of the glacier, called the snout, appears to move back up the valley. The second word is ablation. Ablation means the loss of ice. This can happen through melting, sublimation, or calving. In simple terms, ablation is the part of the glacier system where ice is being lost. The third word is anthropogenic. This means caused by human activity. So, when we talk about anthropogenic climate change, we are talking about climate change driven by human actions, especially the burning of fossil fuels, deforestation, transport, industry, and agriculture. The fourth word is ecosystem. An ecosystem is a community of living organisms interacting with each other and with their physical environment. So, for example, a glacial ecosystem might include cold-adapted animals, mountain plants, meltwater streams, rocks, soils, and the glacier itself. This slide asks an important question. What happens when the world's water towers dry up? Glaciers are sometimes called the world's water towers because they store huge amounts of fresh water as ice. During warmer months, some of this ice melts and feeds rivers. That meltwater can be essential for drinking water, farming, hydroelectric power, and ecosystems downstream. The key idea here is mass balance. A glacier's mass balance is the difference between ice gained and ice lost. Ice is gained through accumulation, mainly snowfall. Ice is lost through ablation, mainly melting. If accumulation is greater than ablation, the glacier gains mass and may advance. If ablation is greater than accumulation, the glacier loses mass and retreats. So, the health of a glacier depends on this balance. Even a small temperature increase can push a glacier into negative mass balance, meaning it loses more ice than it gains year after year. That is why glaciers are so useful for studying climate change. They respond clearly to long-term changes in temperature and snowfall. Before we move fully into climate change, let's quickly recap our previous learning on human uses and conflicts in glaciated areas. Question 1. Which economic activity in glaciated areas involves extracting slate or limestone? Question 2. Why do glaciated U-shaped valleys make excellent locations for HEP or hydroelectric power? Question 3. Name one conflict that arises between tourists and local farmers in national parks. Question 1. The answer is quarrying. This is the extraction of rock, such as slate or limestone. Question 2. U-shaped valleys are useful for hydroelectric power because their steep sides and high rainfall make them good locations for dams. Water can be stored high up and released with force to generate electricity. Question 3. Examples of conflicts include path erosion, litter, traffic congestion, noise, or tourists leaving gates open and allowing livestock to escape. This recap matters because glaciated areas are already under pressure from human activity. Climate change adds another layer of pressure. Now we are moving into the climate science. Since the Industrial Revolution, human activity has increased the amount of greenhouse gases in the atmosphere. These include carbon dioxide, methane, and nitrous oxide. Greenhouse gases trap heat in the atmosphere. This is known as the enhanced greenhouse effect. As more heat is trapped, global temperatures rise. This is what we mean by anthropogenic warming, warming caused mainly by human activity. Glaciers are very sensitive to this warming. As temperatures rise, more ice melts during the warmer parts of the year. At the same time, in some places, precipitation that might once have fallen as snow now falls as rain. This affects the glacier's equilibrium line. The equilibrium line is the boundary between the upper part of the glacier, where accumulation is greater, and the lower part, where ablation is greater. If temperatures rise, the equilibrium line moves higher up the mountain. That means the ablation zone expands and the accumulation zone shrinks. In other words, more of the glacier is melting and less of it is gaining new ice. This is why many glaciers around the world are retreating. But there is an important point: glaciers react slowly. The melting we see today often reflects warming that has been building for decades. That means even if emissions were reduced, some glacier retreat would continue because the climate system and glaciers do not respond instantly. Why might glaciers be described as evidence of long-term climate change rather than just short-term weather? Model answer: because glaciers respond to patterns over many years, not just one hot day or one warm summer. Their retreat shows a long-term imbalance between accumulation and ablation. Now let's look at why melting glaciers matter beyond the mountains. The first major impact is sea level rise. When land-based ice melts, that water eventually flows into rivers and oceans. This adds extra water to the ocean system, causing global sea levels to rise. This threatens low-lying coastal cities such as London, New York, Shanghai, and many others. It can also threaten small island nations, coastal farmland, ports, roads, homes, and freshwater supplies. Sea level rise can increase coastal flooding, make storm surges more damaging, and cause salt water to contaminate freshwater sources. The second major impact is on ecosystems. Many mountain species are adapted to cold, high-altitude environments. Examples include species like the snow leopard and the pika. These animals rely on specific habitats, food sources, and breeding conditions. As glaciers shrink and temperatures rise, habitats shift uphill. But mountains have a limit. Species cannot keep moving upward forever. Eventually, they may run out of suitable habitat. So glacial retreat does not just change the landscape. It changes food webs, water availability, breeding areas, and survival chances for many species. This is why glacial environments are called fragile. When one part of the system changes, it can affect many other parts. Which impact do you think is more serious? Sea level rise or ecosystem collapse? Be ready to justify your answer. Good answers should explain both the impact and the scale. Sea level rise affects millions of people globally, while ecosystem collapse may cause irreversible biodiversity loss. Now we have a true or false question. Melting sea ice, like at the North Pole, is the main contributor to global sea level rise. Remember, I am not just looking for the answer. I am looking for the reasoning. The correct answer is false. Melting sea ice is not the main contributor to global sea level rise. Why? The most important reason is that sea ice is already floating. It is already displacing water. When it melts, it does not add a large amount of new water to the ocean. Think of ice cubes in a glass of water. When the ice melts, the water level does not suddenly overflow because the floating ice was already displacing water. The bigger problem for sea level rise is land-based ice. This includes mountain glaciers and huge ice sheets in Greenland and Antarctica. When land-based ice melts, it flows into the ocean and adds new water. That increases the volume of water in the oceans. So, sea ice melt is still very serious because it affects albedo, ecosystems, and climate feedbacks. But when we are talking specifically about sea level rise, land-based ice is the main concern. So, the correct explanation is option B. Sea ice is already floating. Its displacement is the same whether liquid or solid. Land-based glaciers and ice sheets add new water to the ocean volume. Make sure you remember that distinction. It is a common exam trap. Sea ice melting matters, but land ice melting is the bigger direct cause of sea level rise. Now we are going to look at a specific case study, the Mer de Glace in the French Alps. The name means sea of ice. It is one of the most famous and most studied glaciers in the world. The Mer de Glace is important because it gives us clear evidence of glacial retreat in a high-income European country with a long history of scientific monitoring and tourism. According to the slide, the glacier has lost over 115 meters of thickness in the last 30 years. That is not just the glacier snout moving slightly. That is a major loss of ice volume. Tourism has also been affected. Tourists now have to climb over 500 steps to reach the ice cave. In the past, the ice cave was much closer to the level of the cable car station. This is a very visual example of retreat. People can literally see that the ice is lower than it used to be. There are also environmental consequences. As the glacier thins, the surrounding valley walls can become unstable. Ice can act like support for valley sides. When that ice disappears, rock that was once held in place can become loose, increasing the risk of rock falls. So, the Mer de Glace shows us several impacts at once: loss of ice, tourism disruption, landscape instability, and visible evidence of climate change. Why is a named case study like Mer de Glace useful in a geography exam? Because it gives specific evidence, such as location, measured retreat, and real consequences. This makes an answer more detailed and convincing. Now let's look at three major consequences of glacial retreat. The first is GLOFs, which stands for Glacial Lake Outburst Floods. As glaciers melt, lakes can form in front of or on top of the glacier. These lakes may be dammed by loose material called moraine. Moraine dams can be unstable. If they collapse, huge amounts of water can suddenly rush downstream, destroying villages, roads, bridges, and farmland. The second consequence is water insecurity. Many rivers depend on glacial meltwater, especially during dry seasons. At first, as glaciers melt faster, river flow may increase. But over time, as the glacier shrinks, there is less ice left to melt. Eventually, river flow can decrease, especially in summer. This is a serious problem in places such as the Andes and the Himalayas, where millions of people rely on meltwater for farming, drinking water, and hydropower. The third consequence is the albedo flip. Albedo means how reflective a surface is. White ice reflects a lot of sunlight. Dark rock absorbs more sunlight. When glaciers melt, white ice is replaced by darker rock or water. This means more heat is absorbed by the Earth's surface, which can speed up warming and cause even more melting. This is called a feedback loop. A change starts a process that makes the original change even stronger. So glacial retreat has immediate risks, like floods, and long-term risks, like water shortages and increased warming. What is the difference between a direct impact and a feedback effect? Model answer. A direct impact is an immediate result, such as flooding from a GLF. A feedback effect is when one change causes further changes that strengthen the original process, such as melting ice reducing albedo and causing more warming. Now we need to think about management. How can people protect glacial environments? The first strategy is artificial snow. Snow cannons can be used to add snow and increase mass on parts of a glacier or ski area. This may help in the short term, especially for tourism. However, it is energy intensive and needs large amounts of water. If that energy comes from fossil fuels, it may actually contribute to the problem it is trying to solve. The second strategy is glacier blankets. These are reflective white sheets placed over parts of the ice. The idea is to reflect sunlight and reduce melting. This can work on a small scale, for example around ski resorts or tourist ice caves. But it is expensive and only protects limited areas. You cannot realistically cover an entire glacier or ice sheet with blankets. The third strategy is global policy, such as the Paris Agreement, which aims to limit global warming. This is the most important long-term solution because glacial retreat is mainly driven by global temperature rise. Local strategies may slow melting in small areas, but they cannot solve the overall problem without reducing greenhouse gas emissions. So when we evaluate management, we need to think about scale. Local strategies can protect small areas temporarily. Global strategies can address the root cause, but they require international cooperation and long-term commitment. Which strategy is most effective in the short term? Which is most effective in the long term? Model answer. In the short term, glacier blankets or artificial snow may protect small areas. In the long term, reducing global emissions through international policy is more effective because it tackles the cause of warming. Now let's test that understanding. What is the main limitation of using glacier blankets as a management strategy? Option 1. They pollute the water with plastic chemicals. Option 2. They are only effective on a very small, local scale. Option 3. They actually speed up melting by trapping heat. Option 4. They prevent snow from accumulating in winter. Choose your answer. The correct answer is option 2. Glacier blankets are only effective on a very small, local scale. They may protect a tourist area or an ice cave, but they cannot protect an entire glacier system. This means they are useful but limited. For a strong exam answer, you could say, glacier blankets can reduce melting locally by reflecting sunlight, but they are expensive and only protect small areas, so they do not solve the wider problem of climate-driven glacial retreat. Now we are going to finish with an ethical question. Should rich nations, which emitted the most greenhouse gases historically, pay for the management of melting glaciers in developing nations such as Nepal or Peru? There is no single correct answer here. What matters is the quality of your reasoning. One argument for saying yes is climate justice. If richer countries developed by burning fossil fuels and producing greenhouse gases, then they have contributed more to the problem. Therefore, they may have a responsibility to help countries that are now suffering the consequences. Another argument for yes is that helping to manage glacier risks can reduce future problems. For example, preventing GCSE and water shortages could reduce displacement, conflict, food insecurity, and migration. However, some people might argue no. They may say that it is too expensive or that each country should manage its own land and hazards. Others may argue that money should focus on global carbon reduction instead of local adaptation schemes. A strong answer will consider both sides before reaching a judgment. Here is a student task. Write a short paragraph answering the question. Start with, rich nations should or should not pay for glacier management because. Then include at least one counterargument. You might have said yes, because those who caused the most damage should help pay for repairs. You might also have said yes, because preventing floods, water shortages, and instability helps the wider world. You might have said no because it could be too costly, or because local governments should manage their own land. You might also have said that reducing emissions globally is more important than paying for local fixes. The strongest answers are balanced. They recognize that local management is important, but that long-term protection depends on reducing greenhouse gas emissions. To finish, let's return to the big picture. Glaciers helped shape many of the landscapes we have studied. They carved U-shaped valleys, corries, arêtes, pyramidal peaks, ribbon lakes, and hanging valleys over thousands of years. But today, human activity is changing these environments very quickly. That is what makes this topic so important. We are not just studying landscapes from the past. We are studying landscapes that are changing right now. Glacial retreat affects sea levels, water supplies, ecosystems, tourism, hazards, and communities. Protecting these environments requires both local management and global action. Your final question is, what will you do to reduce your carbon footprint? This could be using less energy, walking or using public transport more often, reducing waste, eating more sustainably, or supporting policies that reduce emissions. The key lesson today is this. Glaciers may seem distant, but their future is connected to decisions made by people all over the world.